Imagine you are standing on a quiet beach at night, with only the hiss of the waves and the glow of the stars for company. The sand ends a few steps in front of you, and then there is darkness and water and nothing else. But that map in your head is wrong. If you could push the ocean aside and walk straight out across the seafloor, you would not find endless flat mud. You would find drowned river valleys, buried forests, and cave mouths hanging in the blue. You would find an entire world that used to be dry land, and once you see that hidden shoreline, a terrifying question appears about what really happened at the end of the last ice age, when the seas rose and the world we know today was born. We grow up with a very simple picture of Earth. There are continents, there are oceans. The edges where they meet feel natural and permanent, like the outline of a puzzle. You can draw it from memory without thinking. For most of us, that coastline is the frame around our mental image of history. Ancient cities sit just inland from the water. Great ports stand where land and sea meet. The shape of the map feels like the background of the story, not part of the story itself. But coastlines are not lines at all. They are only where the ocean happens to stop today. If sea level falls, the continents grow outwards. If sea level rises, they shrink. There is nothing sacred about the place where the last wave laps the sand at your feet. It is just where the ocean and gravity and climate have drawn a temporary border. A border that has moved dramatically many times, including very recently. Right now, most of the land that humans use lies close to those temporary borders. The richest soils, the busiest cities, and many of the oldest settlements cluster along coasts and river mouths. That is true today, and it was almost certainly true in the deep past as well. Which means that if the ocean has surged forward and backward, swallowing and exposing land, the main stage of human history has been drenched and dried more than once. The missing acts of that play may now lie under tens of meters of water. Scientists who study the seafloor have learned to read these missing acts in the shapes beneath the waves. When sonar scans across the continental shelves, it reveals winding channels carved by rivers, now flooded and silent. There are old shorelines stepped down the slope like terraces, marking pauses in rising seas. Divers have found tree stumps rooted in place far off modern coasts, preserved in cold water where they once stood in open air. In some places, cave systems with ancient stalactites end in clear blue nothing, where the rock now drops into the sea. All of this only makes sense if sea level was much lower in the recent past. During the height of the last ice age, around 20,000 years ago, so much water was locked in continental ice sheets that the global ocean surface sat more than 100 meters lower than it does today. Imagine what that does to your mental map. The broad light blue bands around every continent on a modern atlas, the shallow seas that hug the coasts, would have been dry land. Instead of scattered islands, many regions were continuous landmasses. The world would look familiar, but strangely swollen. This is not some weird alternate planet from another era of dinosaur. This is our Earth, with the same continents and the same sky, just colder and drier. A person living then could walk across exposed shelves that are now submarine deserts. They could stand at the edge of cliffs that now plunge into dark water. They could cross land bridges that have since been erased, connecting regions we now think of as separated by deep sea. To them, that map would have felt normal and stable, just as ours does to us. The ice that made this possible was piled up in staggering quantities. Kilometers thick over much of North America and Northern Europe, it buried mountains and crushed forests under its weight. That ice did not appear out of nowhere. It grew slowly as snow fell, compacted, and refused to melt for thousands of years. Subtle changes in Earth's orbit and tilt, known as Milankovitch cycles, shifted how sunlight was distributed across the planet and gave winter a long, slow advantage over summer. Over time, that advantage built continents of frozen water. For a long stretch, this frozen world seemed stable. Sea level stayed low, coastlines held roughly the same position for many generations. Human groups adapted to this reality. They hunted megafauna on the wide plains that stretched across what is now the North Sea. They followed rivers that now lie beneath the Gulf of Mexico. They may have built camps and seasonal gathering places where modern fishing boats move today. The people who walked that world had no reason to think their map would ever change. Yet even in that apparent stability, the system was loaded with potential energy. An ice sheet is not a static block. It is a moving, creaking flow of frozen water balanced delicately between accumulation and melting. Beneath its surface, meltwater can pool in vast hidden lakes. At its edges, the ice may rest behind ridges and sills that can fail suddenly. All it takes is a modest shift in temperature or a change in where meltwater flows for that balance to break and for stored water to be released. When the planet began to warm out of the last ice age, that stored water started to move. In school textbooks, the story is usually told as a smooth, gradual rise in sea level, unfolding lazily over thousands of years. That picture is true on very long timescales, but when scientists looked more closely, a very different pattern emerged. Instead of one gentle climb, they found steps and surges, periods when the ocean rose fast, then slowed, then jumped again. These bursts are known as meltwater pulses, and they change everything about how we imagine the end of the Ice Age. Some of these pulses were almost unimaginably intense. Evidence from coral reefs and seafloor sediments suggests there were centuries when sea level climbed by many meters in a relatively short time. That is still long compared to a human life, but it is short compared to the slow grinding of ice sheets. It means a child could grow up on a coastline and live to see the sea well inland from where it was when they were born. For people tied to coastal hunting grounds, fishing spots and sacred sites, that change would feel like a relentless, unstoppable flood. And those were just the slow parts. On top of the background of rising seas, there were individual catastrophes when ice dams burst and proglacial lakes tore free. In these events, water the size of inland seas could drain in days or weeks. Downstream landscapes were scoured, rock was ripped from bedrock, and boulders larger than houses were moved like pebbles. We can still see the scars of such events today in places like the scablands of the American Northwest. Deep channels and giant ripple marks are frozen proof that entire regions were stripped bare in the rush. Now imagine experiencing these changes not as a scientist with maps and graphs, but as a coastal hunter watching the familiar world disintegrate. Shores collapse, rivers change course, lowlands become marsh, then bay, then open water. Villages that once sat safely back from the waves find their paths to the forest cut off by tides, then their central fires drowned. People move inland, crowding into territories already claimed, spark conflict and migration. To them, it would feel as if the ocean itself had decided to invade. The idea of a single great flood that ended the Ice Age is not a simple yes or no question. The Ice Age did not stop in one afternoon under a single wall of water. Yet from the point of view of cultures living on vulnerable coasts, the end of the Ice Age could easily look like a drawn-out but very real global flood. Not global in the sense that every river on Earth rose on the same day, but global in the sense that coastlines everywhere were stepping inland, swallowing land after land. When you think about it this way, the stories that ancient civilizations tell about overwhelming floods start to feel less abstract. Myths from Mesopotamia, early stories that later inspired the tale of a man building a great vessel to ride out rising waters, may carry echoes of real flood disasters in low-lying river valleys. Traditions from indigenous peoples along the Pacific and Atlantic coasts sometimes speak of ancestors forced to flee as the sea ate their land. Even in the modern era, families remember villages that were once on dry ground and are now beneath the waves. All of these memories are scattered and filtered through generations of retelling, symbolism, and religious meaning. But underneath that, there may be a simple pattern. When the sea rises quickly compared to your life, it does not feel like gentle climate change. It feels like punishment, or fate, or the anger of gods. It feels like something that demands a story big enough to carry the shock. We happen to be the first generation with the tools to compare those stories to physical evidence written in ice and stone and submerged landscapes. This is where the tension really lies. For decades, mainstream science tended to downplay the role of sudden catastrophe in shaping recent Earth history. The emphasis was on slow processes, incremental erosion, and gradual climate shifts. Catastrophes were reserved for deep time events like asteroid impacts and massive volcanic eruptions. The idea that the last few tens of thousands of years might include violent episodes big enough to erase coastlines felt uncomfortably close to myth. Yet evidence for rapid flooding and abrupt climate swings at the end of the Ice Age has become too strong to ignore. At the same time, more speculative thinkers have run in the opposite direction, proposing lost advanced civilizations destroyed in a single night of chaos. That picture stretches well beyond the available evidence and often borrows more from fiction than geology. Still, it is driven by a real puzzle. We know sea level rose by more than 100 meters from the last glacial maximum to today. We know humans were present on Earth throughout that entire period. It would be strange if no complex coastal societies ever formed on the now drowned shelves during all that time. So we find ourselves caught between two unsatisfying extremes. On one side, a picture of the past that is almost too calm, with human history unfolding gently on a stable stage. On the other, a vision of endless catastrophe, wiping out forgotten empires in a way that leaves almost no trace. The reality, as usual, is likely somewhere in between, but it may still be far more dramatic than most of us were taught in school. To make sense of it, we need to rebuild the lost world piece by piece. We can start by changing how we look at something as simple as a map. Next time you see the outline of the continents, imagine drawing a new shoreline 100 meters lower. Visualize the broad platforms around each landmass turning from ocean to grassland and forest. Picture how many of our modern ports would sit far inland, and how many new coasts would appear on the edges of the deep basins. That mental exercise gives you a hint of how much real estate vanished beneath the waves as the Ice Age ended. Now bring that image back to the beach where we began. You are still standing on the sand, listening to the waves. Somewhere beyond the breakers lies the old coastline, the one that existed when mammoths still walked and humans followed game across the exposed shelves. Beyond that, the slope drops off into the deep ocean that has been there for far longer than any ice sheet. Between the present shore and that ancient drop-off is the strip of lost world, a drowned archive of human and natural history. It is not an archive we can easily read. Underwater archaeology on the continental shelves is difficult and expensive. Visibility is often poor. Sediments bury structures and artifacts. Many sites may have been destroyed by wave action as the water advanced, or by later storms. But we are beginning to develop the technology to scan these landscapes in detail, from high-resolution sonar mapping to autonomous underwater vehicles. Each new survey reveals channels, terraces, and sometimes cultural traces that force us to rethink how people moved and settled as the seas rose. All of this leads back to the question that pulled us into this investigation. If the end of the last ice age involved real floods on a planetary scale, what exactly happened 12,000 years ago when climate lurched and sea level surged? To answer that, we need to leave the beach for a moment and step onto the ice itself, into a world where the air is sharper, the continents are heavier, and almost everything we take for granted about coastlines and climate is turned inside out. The air on that frozen earth would sting your lungs the moment you stepped outside. Sky and land would feel sharper, colours drained toward white and grey, sounds muffled under endless snow. Where today we see fields, forests and cities, you would see pale ice stretching to the horizon, broken only by ridges and blue crevasses that fall into shadow. The familiar map is still there underneath, but the surface has been completely rewritten by cold. If you could hover above the planet and look down, the change would be obvious. North America's northern half would be buried beneath a dome of ice that swallowed mountains and flattened valleys. Northern Europe would sit under its own frozen shield, stretching from the British Isles across Scandinavia and deep into the continent. Glaciers would snake out along high ranges in Asia and South America, their tongues pushing down into lower land, grinding rock into fine powder. Closer to the equator, the picture would be different but still strange. Where we see shallow seas today, you would see broad plains. The shelf around Southeast Asia would be a continuous block of land connecting what we now call mainland Asia, the islands of Indonesia, and the separate continents of Australia and New Guinea. The Persian Gulf would be a dry basin cut by rivers. The North Sea would be a cold, windy grassland where herds could graze and people could walk from what is now Britain to continental Europe. The climate that made this possible was not just colder, it was drier and dustier in many regions, with strong winds carrying fine rock flour scraped from under the ice. Greenhouse gas levels in the atmosphere were significantly lower, locking in a steady chill. Winters lasted longer, summers were short, often too weak to melt the heavy snowpack at high latitudes. Over thousands of years, snow that refused to melt turned into ice that thickened and spread. Behind that transformation were small, predictable changes in the way our planet moves. Earth's orbit is not a perfect circle. It stretches and relaxes over long cycles, changing how much solar energy reaches different latitudes. The tilt of the planet's axis slowly shifts as well, altering the contrast between seasons. Even the direction in which the axis points in space traces a long, slow wobble. Each of these cycles on its own is modest. Together, they can push high-latitude climates toward long winters or long summers. During the last glacial maximum, the balance tipped decisively toward winter. Snowfall over northern continents outpaced melting year after year. As ice sheets grew, they reflected more sunlight back into space. That reflection made the planet even colder, which let the ice grow still more. It was a self-reinforcing loop that lasted for tens of thousands of years. From the perspective of tiny human lives, the ice was simply there, as permanent as the mountains it covered. Yet even in this deep freeze, Earth was not dead. Far from it. Between the great ice caps lay wide belts of steppe and tundra, with hardy grasses, shrubs and scattered trees. Herds of megafauna moved across these landscapes, following the seasons. Woolly mammoths, with massive curved tusks and thick coats, browsed on frozen plains. Woolly rhinoceroses trundled through scrublands. Giant ground sloths clawed at trees in the Americas. Saber-toothed cats and packs of large predators hunted the herds. Among them moved small groups of humans. They were physically the same species as you and me. They carried children, tools and stories, and they made choices every day to stay alive in a harsh world. Many followed migratory routes, shadowing the great animals, harvesting meat, bone, hides and fat. Others exploited river valleys where water carved pathways through cold land and fish gathered when seasons allowed. Some lived at the margins, along the edges of ice or coast, where different environments touched. If you could sit with one of these groups by their fire, the map in their minds would be rich and detailed, but nothing like ours. They would know the location of particular springs, narrow passes, and sheltered groves. They would be able to describe the shape of a distant ridge or the bend of a river with absolute clarity. Yet the shape of continents and oceans, the whole planet seen from above, would mean nothing. For them, the world ended where their trails ended. Now imagine walking with them toward what we would call the coast. As you descended from the interior, you would cross a broad plain that does not exist today. Rivers would wander across it, splitting into channels and rejoining before finally finding the sea. In some places, dunes and dry ground would dominate. In others, wetlands and shallow lakes would spread out, full of birds and fish. Far away, a low line on the horizon would mark the true shore, where waves crashed against sand or cliffs. These exposed shelves were prime real estate. They offered access to both land and sea resources. Shellfish beds, tidal pools, and shoals full of fish lay just beyond the high tide line. Inland, game came down to drink at river mouths. Driftwood and other materials washed up on beaches. For a mobile coastal culture, this zone would be a highway and a supermarket combined. Paths would crisscross it, and seasonal camps would pop up in places where everything came together. Because sea level was relatively stable for long periods during the peak of the Ice Age, generations could live and die in these spaces without seeing much change. There might be slow shifts, a river cutting a new channel, a spit of sand slowly growing or eroding. Storm surges would come and go, but the broad shape of the land, where dry ground ended and water began, would feel fixed. Elders would tell children that this is how things have always been. Of course, people still had to navigate risk. Storms could wreck boats, ice could crack underfoot. Predators could ambush hunters on open ground. But the background frame of the world seemed solid. The ice sheets were like distant mountain ranges. The coastlines were like the edge of the known Earth. There was no reason to suspect that both were temporary features in a much larger, slower drama. Under the surface, though, that drama was already in motion. Ice is not a rigid rock. It flows under its own weight, creeping outward from thick centres toward its edges. At those edges, ice tongues extend into lower, slightly warmer ground. Summers are short but not non-existent, so melting still happens at the margins and on the surface. Meltwater trickles down through crevasses, collecting in hidden channels under the ice and in huge glacial lakes that sit trapped behind ridges of frozen and rocky debris. Think of these lakes as reservoirs built by nature, held back by walls that were never designed to last. The dams were made of ice, slush and piled rock, constantly stressed by the growing weight of water behind them. Sometimes the walls held for centuries, sometimes they failed. When a dam gave way, the stored water did not politely stroll out. It surged, tearing at its own outlet, carving deeper channels and dragging blocks of ice and rock along with it. We can see the footprints of these old catastrophes today. In some valleys, there are giant scour marks where bedrock was polished and gouged by fast-moving, sediment-rich water. Elsewhere, we find long, streamlined hills of gravel and till that formed under flowing ice, showing the direction of past movement. Fields of boulders, known as erratics, sit far from any matching bedrock, dropped there when ice or floodwaters lost their strength. Each feature is a clue that the frozen landscape was far more dynamic than a simple sheet of snow. While all of this was unfolding in the far north and south, the rest of the world responded in its own way. Tropical regions were not buried under ice, but they felt the global chill. Rainfall patterns shifted. Some areas that are now lush rainforest were drier and more open. Others may have been wetter. Dust from glaciated regions travelled long distances, influencing climate and soil fertility elsewhere. Feedback loops between vegetation, ice and atmosphere wove a complex tapestry that we are still trying to fully understand. Through all of this, humans adapted. They were astonishingly flexible, adjusting their hunting strategies, toolkits, and migration routes to the conditions they encountered. Groups moved into new territories when resources opened up, then pulled back when ice advanced or climate shifted. Over many thousands of years, they spread to nearly every continent, including the exposed shelves and corridors created by low sea level. By the time the planet started to warm in earnest, people were everywhere that ice did not dominate. That warming did not arrive as a single dramatic sunrise. It began quietly as orbital cycles shifted and greenhouse gas levels in the atmosphere started to climb. The thickest parts of the ice sheets were slow to respond, but the margins began to thin. Summers grew slightly longer and more effective at melting snow. Meltwater trickled sooner, pooled deeper, and flowed more widely. Rivers that once ran sluggishly at the edges of ice gained strength and length, nibbling away at fragile dams. If you were living near one of these frozen edges, you might notice that the river ran higher each summer than the last, or that the face of the glacier had retreated a little further uphill. You might see new streams appear where there was once only rock. On their own, these changes were subtle. They could just as easily be filed away as the normal ups and downs of weather. Yet together, they were signs that the system was passing a threshold. Inside the ice sheets, the story was the same. As surface melting increased, more water found its way downward, lubricating the base of the ice and speeding its movement. Lakes beneath the ice filled faster. Glacial dams that had held firm for centuries now had to endure greater pressure. In some cases, they might have partially failed and then refrozen, creating complex structures that were even more unstable. To the people on the surface, the ice still looked solid. Beneath, it was becoming increasingly hollowed out. From a planetary perspective, the situation now looked like a coiled spring. Vast quantities of water were stored in mechanical arrangements that could release it quickly if triggered. Cliffs of ice, hundreds of meters high, loomed above warming oceans. Inland, proglacial lakes held volumes rivaling small seas, pressed up against weak walls. It did not require a massive extraterrestrial impact to unleash these reservoirs. The steady, relentless push of warming was enough. At the same time, sea level around the world was responding. As more ice melted, the global ocean began to rise, inch by inch. It was not a smooth, uninterrupted climb. There were pauses when melting slowed and the ocean seemed to catch its breath. Then there were intervals when the rise accelerated sharply, reflecting pulses of meltwater released from the ice sheets. Coral reefs that grow close to the surface of the sea recorded these jumps in their layered skeletons, like rings in a tree. For the human communities living on the ancient continental shelves, those pulses would translate into a creeping sense that something had changed. A fishing spot that had been shallow, wadable water might now be too deep to stand in. A sandbar that once appeared at low tide could vanish permanently. Freshwater springs near the coast might turn brackish. These hints were easy to ignore in isolation, yet taken together, they signalled that the boundary between land and sea was moving. We know from our own time how hard it can be to respond to slow-moving threats. Even when scientists show clear data, daily life has a way of pulling attention back to immediate problems: food, safety, conflict, weather. For Ice Age peoples, the luxury of long-term planning was even rarer. They had to prioritise the next hunt, the next migration, the next shelter from a storm. The deep structural changes in climate and ice would have been invisible to them, even as the consequences crept closer. What they would notice, acutely, were the rare moments when the background rumble of change exploded into a roar. An ice dam that had held back a vast lake for centuries could fail without much warning at the surface. A narrow outlet tunnel might grow slowly at first as water trickled through, then suddenly widen as the flow carved and melted its own path. Once that process crossed a tipping point, the dam would disintegrate in a rush. When that happened, all the careful balance of the frozen world would reveal its other face. Stable ice would turn into a collapsing wall. Quiet lakes would transform into plunging torrents. Valleys downstream would face walls of muddy, debris-laden water that outran any animal. Whole landscapes would be stripped bare, scoured down to bedrock, then buried under chaotic layers of gravel and boulders. Any human group caught along those routes would witness devastation on a scale that would sear itself into memory. From orbit, such an event would look like a sudden shiver in the planet's circulatory system. Rivers would swell in days from narrow lines to broad, churning bands. New channels would cut across previous drainage patterns. Sediment clouds would pour into coastal waters, staining them pale from space. Later, when everything calmed down, the coastline would not be the same. In some regions, deltas would have jumped forward. In others, erosion would have bitten into the land, abandoning previous channels. From the ground, the experience would be far more visceral. Imagine standing in a broad valley you know well, with familiar hills on either side and a slow river in the middle. Clouds gather upriver on a day that feels a bit warmer than usual. At first you might hear a distant rumble, like thunder that does not fade. Then the wind shifts. A smell of cold and silt rides the air. The sound grows louder until it becomes a continuous roar, and the ground under your feet begins to tremble. You might climb a nearby slope, confused, as the river below swells far beyond any normal flood. Within hours, it is no longer a river. It is a moving wall of mud, ice, uprooted trees and shattered rock, filling the entire floor of the valley. Whole stands of forest disappear. Large animals try to flee and are swallowed. As the front passes, it leaves behind a raw, new landscape that bears little resemblance to the one you knew. The mind scrambles for explanations that can hold such a sight. Events like this did not happen every year. They may have been rare on any one river or valley. Yet across the whole planet, in the complex web of ice sheets and proglacial lakes, there were many opportunities for similar failures. Each one released a burst of water into the global system, adding to the sea and feeding the pulses we now see in geological records. With every surge, the Ice Age world loosened its grip a little more. If we want to understand how the end of the last Ice Age could feel like a series of great floods rather than a slow melting, these outburst events are a crucial piece. They bridge the gap between the silent, almost abstract movement of orbital cycles and the very real, very fast destruction of landscapes that people depended on. They show us how a planet can store up catastrophe in the thickness of ice and then spend it in short, violent bursts. The stage is now set. We have a world loaded with frozen water perched in unstable formations, a climate that is shifting toward warmth, and countless human communities living downstream of ice and along coasts that are already beginning to move. The next step in this story comes when one of those fragile barriers fails on a scale so vast that it leaves scars visible from space and legends that echo in human stories. When we talk about great floods at the end of the Ice Age, one place keeps coming up again and again: the northwestern corner of North America. On a modern map, it looks like a familiar landscape of rolling farmland, rivers, and dry plateaus. Yet hidden in that surface are scars so large that for a long time, nobody believed what they were actually saying. Those scars tell the story of one of the biggest freshwater catastrophes the planet has ever seen. To understand it, picture an enormous lake trapped in the shadow of an ice sheet. This was not a quiet alpine lake tucked between peaks. It was a body of water larger than many of today's great inland seas. It sat where the Rocky Mountains met the edge of the Cordilleran ice sheet, in what is now the American Northwest and parts of Canada. Its waters were held back not by solid stone, but by a tongue of glacial ice that filled a valley like a blue-white dam. This lake, which geologists later named Glacial Lake Missoula, filled and refilled many times. Snow and ice melt from high ground fed it slowly, raising its surface over years and decades. The ice dam at its outlet looked strong from the outside, a towering wall of frozen water jammed between the valley sides. People living downstream at the time would have seen a white barrier on the horizon and a calm river in front of them. There was no obvious sign that the valley was effectively plugged with a bomb. Inside the dam, the story was different. Ice is riddled with fractures and air bubbles. It warms from the sun and from the pressure of its own weight. Water seeps through it and under it, searching for any possible path downward. As the lake rose, pressure at the base of the dam increased. Tiny trickles of meltwater in its belly could grow into channels. Each drop that flowed carried a little heat. Each bit of heat opened the path a little more. At first, that melting would have been almost impossible to notice. A small tunnel at the base of the ice might let a modest flow sneak through. Some winters, that channel might even freeze shut again. But as the climate warmed and the lake rose higher, the balance shifted. In one of those years, the rate of melting finally outpaced the rate of refreezing. Flow through the tunnel increased. Warmer lake water poured in to replace what escaped, feeding the process. Then the tipping point arrived. The narrow tunnel widened under the stress of the rushing water. The walls began to collapse. More ice fell into the flow, where it melted or was pushed aside. Pressure at the base dropped in a runaway cascade. At some moment, perhaps over the course of just a few hours, the entire dam ceased to be a dam at all. It became part of the flood. The release of Glacial Lake Missoula is hard to visualize because our everyday experience has nothing like it. Imagine the combined flow of all the rivers on Earth, then imagine even that is still too small. Water hundreds of meters deep thundered out of the mountain basin through the dam breach. It roared down valley at highway speeds, thick with mud, stones and blocks of ice. Where it met obstacles, it did not meander, it simply sheared them away. This was not a single tall wave like those shown in disaster movies. It was a sustained outpouring, a plateau of water and debris that poured across the land for days. Whole hills were planed down, ridges were cut into sharp channels. The flood stripped soil from wide areas, leaving behind bare bedrock. It carved canyons so large that when later settlers first saw them, they assumed only long rivers with millions of years could have done the work. The land it created is now known as the Channeled Scablands. If you fly over them or look at satellite images, you see a wild maze of deep gashes, braided channels, and isolated mesas. Giant ripple marks, far larger than any beach pattern, lie frozen in place on old lake beds, with wavelengths measured in tens of meters. Boulders the size of houses sit stranded on high ground, with no obvious source. Every feature whispers the same story. A lot of water moved through here very fast. For decades, the idea that a single or repeated set of floods could have produced all this seemed too extreme. Early geologists who proposed catastrophic flooding were dismissed as throwbacks to myth thinking. The dominant view was that slow, steady processes explain almost everything. Rivers erode their banks, rain eats away at rock. Over vast stretches of time, these patient agents can carve grand landscapes. Why appeal to monstrous floods when ordinary ones will do? The problem was that ordinary floods could not account for the specific shapes and scales involved. As more evidence accumulated, the catastrophic interpretation became harder to avoid. Hydrologists ran calculations on how much water would be needed to form the scablands in a short time. The numbers were staggering, but consistent with a lake the size of Missoula draining rapidly. Field surveys found repeated layers of flood deposits, suggesting that the scenario played out many times. Once researchers accepted that this kind of outburst flood could happen in one region, they began to look for similar signatures elsewhere. It did not take long to find them. Eastern Washington was not unique. In many formerly glaciated valleys around the world, there are oversized channels and gravel bars that do not match modern rivers. The shapes of some basins suggest they once held large lakes trapped by ice that later failed. In Europe and Asia too, there are hints of past megafloods tied to retreating ice. At the time these floods were ripping through their local landscapes, they were also feeding something much bigger. All that fresh water was not staying in valleys forever. It was heading to the sea. When lake after lake emptied, and when shelves of ice collapsed into warming oceans, global sea level responded. Meltwater pulses show up as rapid jumps in the height of the sea, recorded in coral reefs and in the chemistry of marine sediments. Corals are particularly useful witnesses. Many species grow in a narrow band of water close to the surface, adjusting their growth as sea level changes. When they die, their skeletons remain, locked at the depth where they formed. By dating these skeletons and mapping their positions, scientists can reconstruct the rise of the ocean over time. The picture they see is not a simple ramp, it has steps. Some of those steps align with the kinds of outburst events we have been exploring. One of the most important of these bursts of water likely came from a different giant lake far to the northeast. This was Glacial Lake Agassiz, a vast inland sea that once stretched across what is now central Canada and parts of the northern United States. Fed by the melting Laurentide ice sheet, it covered an area larger than many modern countries. As long as the ice blocked its northern outlets, it drained slowly southward. But as the ice margin retreated, new pathways opened. At certain times, those pathways may have changed abruptly. One scenario, supported by geological evidence, suggests that Lake Agassiz suddenly dumped a huge volume of fresh water into the North Atlantic when its drainage switched. Instead of slowly trickling toward the Gulf of Mexico, it spilled out across eastern Canada and into the ocean. This would have happened as ice dams and ridges that once held back the lake gave way or were overtopped. The consequences of such a rerouting go beyond simple sea level rise. The North Atlantic is one of the engines of global ocean circulation. There, salty surface water cools, becomes dense, and sinks, helping drive a conveyor belt of deep currents that redistribute heat around the planet. Dumping an enormous amount of fresh water into that region would make the surface less salty and less dense. That in turn could weaken or even temporarily stall the sinking motion. If the sinking slows, the entire heat transport system is disrupted. Regions that normally receive steady warmth from ocean currents can cool quickly, even as the planet overall is warming. Ice cores from Greenland show just such abrupt shifts. Temperatures recorded in trapped air bubbles swing from near glacial chill to milder conditions and back again on timescales as short as decades. After long periods of gradual change, the climate seems to lurch, as if nudged by external shocks. This is where the story of ice dams and floods connects directly to one of the strangest episodes at the end of the last ice age, a period when the planet, which had been warming out of the glacial deep freeze, suddenly snapped back toward cold. This interval is known for one small mountain flower that grew in the tundra and left its pollen behind as a marker in lake sediments. It is called the Younger Dryas. The name sounds technical. The event it labels was anything but gentle. Before we zoom into that abrupt reversal, it is worth pausing on what we have already seen. We started with a world locked in ice, where coastlines sat far out from their modern positions. We followed the slow build-up of tension as ice sheets thickened and stored more and more frozen water. We have now watched that tension begin to uncoil through outburst floods big enough to remodel entire regions in a geological instant. Each of those floods contributed to a global rising tide. From the perspective of human communities, there are two layers to this drama. The local disasters, like the draining of glacial Lake Missoula, would have been unforgettable shocks for anyone in their path. Even if only one person in 100 miles saw the flood directly and survived, they would tell others. Their story would spread, embellished, turned into cautionary tales or sacred narratives. It would be hard to forget a wall of water that stripped a valley to bare rock. The global consequence, the gradually rising oceans swallowing coastal lands, would have been harder to grasp, but just as real. People whose grandparents had hunting grounds on now drowned plains would have to move inland. Those who relied on rich estuaries and marshes would be squeezed between advancing water and other groups already living on higher ground. Conflicts over resources could sharpen, trade routes would shift, places that once seemed central could become marginal. When we put all this together, the peaceful picture of the end of the Ice Age falls apart. It was not a gentle thaw. It was a long series of stress tests, imposed on both the planet and on the species trying to make a living on its surface. The rising sea and the violent outbursts from collapsing ice dams were two aspects of the same process. They turned the edges of continents into unstable zones where the very shape of the land refused to hold still. You might wonder how many times human groups had to reinvent their sense of home during this transition. A camp near a river might be safe for many generations, then vanish when a flood carves a new channel. A seasonal site on a coastal plain could become a tidal flat within a few lifetimes. Whole regions might slowly empty of people as resources vanished, while other areas suddenly became more attractive as new lakes and rivers appeared. The map in human minds had to be rewritten again and again. This constant redrawing of boundaries is part of what makes it hard for us to trace those earlier cultures. Many of the places where they concentrated their efforts are now at the bottom of shallow seas. Their trails and campsites were not carved into bedrock that would endure for millions of years. They were woven into soil, forest and sand, which do not last long under waves. The floods that forced them to move may also have destroyed much of their physical record. Yet the planet itself has kept at least some of the marks. When we study the scablands, or the terraces cut by outburst floods in other valleys, we are reading a kind of slow-motion crime scene left by water. The channels show where it ran, the boulders show what it carried. The layers of sediment reveal which floods were largest and which were smaller aftershocks. Each line of evidence brings us closer to understanding the sequence and scale of events as the great ice dams failed. What emerges is a picture of the late glacial world as a place of flickering stability. Centuries of relative calm could pass, during which people and ecosystems adapted to a new normal. Then a dam would break, or an ice front would collapse, and a pulse of fresh water and devastation would ripple through the system. After the chaos, a new equilibrium would settle in, slightly different from the one before. Sea level would be higher, coastlines would be a little further inland, habitats would be rearranged. This pattern of stepwise change is important because it means that our ancestors did not face one single crisis and then recover. They faced a series of them, scattered across regions and generations. Each event would have felt local and unique. A devastating flood here, a strange shift in weather there, a river that never behaved the same way again. Only from our vantage point thousands of years later can we see how they were all part of the same global restructuring. So far, we have looked mostly at the mechanical side of that restructuring. Ice, water, gravity, melting. But the climate system is not just a pile of physics, it is also a dynamic web of feedbacks. Change one piece and others respond in surprising ways. When huge floods from lakes like Missoula and Agassiz reached the oceans, they did more than push sea level up. They also changed how heat and salt moved around the planet. That in turn changed where ice could grow or melt. Sometimes those feedbacks cancel out small disturbances. At other times, they amplify them. In the closing chapters of the Ice Age, the latter seems to have happened. The freshwater pulses did not just nudge the climate, they may have helped trigger a dramatic swing that almost threw the planet back into the freezer just as it was escaping. This is where the Younger Dryas comes back into the story, not as a dry technical label, but as a real global shock. In the next step of our investigation, we will follow that shock from the ice sheets and lakes we have been exploring into the wider climate system. We will trace how a surge of fresh water can flip ocean circulation, how that flip shows up instantly in ice cores and slowly in rising and falling forests, and how people living through it might have interpreted a world that warmed, then snapped back to cold, then warmed again. If you could hold a cylinder of ancient ice from Greenland up to the light, you would be looking at time made visible. Thin bands would mark each passing year, pale for winter, slightly darker for summer. Trapped bubbles of air would hold tiny samples of the atmosphere, as it was when mammoths walked and humans followed them. Dust and ash grains would mark storms and distant fires. In that slender record, the end of the Ice Age does not look like a smooth fade from cold to warm. It looks like a heartbeat that stuttered. For a long stretch after the last glacial maximum, the trend in those ice cores is clear. The planet is cold, but inching warmer. Temperatures rise in fits and starts, greenhouse gas levels climb, and the big ice sheets begin to thin. Forests push northward again. Glaciers retreat from valleys they have filled for thousands of years. Coastlines respond with slow, steady advances of the sea over the exposed shelves. It is not a peaceful world, but the direction of change seems consistent. Then, a little less than 13,000 years ago, the line in the ice cores bends sharply the other way. In a geological blink, temperatures in the North Atlantic region plunge back toward values seen during the full glacial period. The chill does not last a single winter or a bad decade. It settles in for more than 1,000 years. This cold relapse is what scientists call the Younger Dryas. The name comes from a hardy tundra flower whose pollen suddenly reappears in sediment, a small plant announcing a big climatic shock. What makes the Younger Dryas so unsettling is not only that it happened, but how fast it began and ended. In some ice core records, the transition into cold conditions seems to unfold over only a few human lifetimes. The exit at the end, when warmth returned for good, may have been even quicker. Imagine several generations growing up in a harsher, drier, windier world, then having their grandchildren suddenly experience much milder winters and shifting storms. This is not the slow background hum of orbital cycles. It is climate on fast forward. So what could make the climate system whip back and forth like this, just as the planet was climbing out of an ice age? The leading explanation ties directly into the floods we explored earlier. Remember that huge inland lake pinned against the edges of the Laurentide ice sheet, the one we now call Glacial Lake Agassiz? As ice retreated and the landscape beneath it changed, the exits from that lake were also changing. At some point, a large fraction of its water seems to have found a sudden new path to the North Atlantic. Under normal conditions, salty surface water in the North Atlantic cools, becomes dense and sinks. That sinking helps power a global conveyor of currents that carry heat from the tropics toward higher latitudes and return cold, deep water southward. If you pour a massive amount of fresh water into that region, you dilute the saltiness of the surface layer. Fresher water is less dense. It is more reluctant to sink. If enough of it spreads across a wide area, the overturning circulation can weaken or even stall. Models and evidence suggest that something like this happened at the start of the Younger Dryas. A huge pulse of meltwater, perhaps from a sudden rerouting of Lake Agassiz, may have flowed into the North Atlantic instead of draining south. That would have formed a cold, fresh lens on the surface, smothering the normal sinking of salty water. With that pump slowed, less heat would have been carried north, winters would bite harder, sea ice could extend further. The land around the North Atlantic would cool quickly, even while some other regions of the planet continued their longer-term warming. You can see hints of this pattern in the way different records behave. Greenland ice cores show a dramatic temperature drop. European pollen records show forests retreating and tundra flora returning. Yet in some parts of the southern hemisphere, the signal is muted or even opposite in timing. The climate system is not a simple thermostat. Push on one part and the effects ripple unevenly, sometimes out of phase. Still, the overall impression fits the idea of a circulation shock rather than a global dimming of the sun. For many researchers, this meltwater rerouting hypothesis is enough to explain the Younger Dryas. It connects known ingredients: retreating ice sheets, large proglacial lakes, a sensitive overturning circulation in the North Atlantic. It fits with the pattern of rapid cooling in that region, followed by a recovery once the fresh water pulse fades and the circulation re-establishes itself. It does not require anything falling from the sky. The drama comes entirely from Earth's own stored water and the way it is released. Yet not everyone is satisfied with this picture. Some scientists and independent researchers have pointed to another line of evidence that seems to cluster around the start of the Younger Dryas. In thin layers of soil and sediment dating to that time at sites across parts of North America, Europe and the Middle East, they report finding unusual materials. Tiny glassy spherules formed by intense heat. Elevated levels of certain elements associated with extraterrestrial material. Microscopic diamonds that can form under extreme pressure and temperature. Along with these strange particles, there are hints of widespread fire. Charcoal layers become thicker. Soot markers increase. Some propose that these signs together point to a different kind of trigger, a comet or asteroid, perhaps already fragmented, entering the atmosphere and exploding over the ice sheets or continents. In this scenario, multiple airbursts or impacts could have ignited massive wildfires, injected dust and vapor into the atmosphere, and destabilized the remaining ice in ways that accelerated melt and fresh water release. This idea is known as the Younger Dryas impact hypothesis. It is controversial, to put it mildly. Supporters argue that it explains the suddenness of the transition, the apparent spike in burning, and the presence of unusual materials in that narrow time slice. Critics respond that many of the claimed markers are not unique to impacts. Industrial contamination, local fires, and other processes can produce similar signals. Some follow-up studies have failed to replicate the more dramatic findings. There is no agreed-upon crater of the right age and size. The debate has been intense because it touches not just on climate science, but on archaeology and human history. If a major impact or series of airbursts happened over North America, it could have contributed to the extinction of many large animals there and to major disruptions in human cultures. That possibility makes the story emotionally charged. Some people are drawn to the idea of a skyborne catastrophe that resets the world in a single generation. Others see a risk of forcing a dramatic narrative onto data that may not support it. From our vantage point, we can step back from the heat of the argument and ask a few key questions. First, do we need an impact to get a Younger Dryas-style event? The answer appears to be no. The climate system on its own, with the known ice sheets and lakes and circulation, is capable of producing abrupt swings when pushed by meltwater pulses. Second, are there signs of something unusual happening around the start of the Younger Dryas, besides simple cooling? The answer here seems to be yes. There are hints of increased burning and odd materials in some places, even if their interpretation remains disputed. For the purposes of our story, what matters is less which exact trigger won the day, and more what the world felt like for those living through the consequences. Whether the main shove came from a huge flood of fresh water, or from something exploding in the upper atmosphere, the outcome in many regions would be similar. The climate would turn harsh again after a period of relative improvement. Glaciers that had retreated might stabilize or even advance. Growing seasons would shorten, drought patterns would shift. Imagine being part of a community in what is now Europe or the Near East at that time. Your parents and grandparents have told you stories about winters that used to be even worse, when ice gripped the land more tightly. They have also told you that things have been getting easier. Snow melts earlier, animals find more grazing on higher slopes, rivers stay unfrozen longer. Maybe your group has started to experiment with planting seeds in reliable patches and staying in one place a little more often. Then, over a human lifetime or two, the direction of change flips. Winters deepen again, summers become less dependable. Crops that seemed promising fail more often. Herd animals face more stress and move differently. Floods and droughts appear in new sequences. In colder northwestern regions, ice that everyone assumed would keep shrinking stops or thickens. If you had woven the earlier warming into your story of the world as a sign of favour or progress, this reversal would feel like a cosmic betrayal. At the same time, the seas do not suddenly fall back. The water already added to the oceans by earlier melting does not drain away. Coastlines that have retreated inland stay there. In some areas, continued melting from other sources may keep sea level rising even during the cold snap. The Great Flood, in the sense of rising seas swallowing the continental shelves, is still underway. The Younger Dryas is a cold interruption layered on top of that ongoing advance. This double movement is unsettling. On land, in many places, life appears to swing back toward glacial severity. Along coasts, the ocean keeps creeping forward. High latitudes feel more like the old world of ice, but with less of the old stability. Low-lying coasts feel like a new world, where the shore never stops moving. For humans and animals trying to navigate these overlapping trends, the sense of a reliable baseline erodes. If an impact or airburst did occur, even as part of a complex chain of events, the immediate visual spectacle would have been unforgettable. Brilliant flashes in the sky, shockwaves flattening forests, firestorms racing ahead of the blast in dry regions, a rain of strange stones and glassy droplets. Many researchers are skeptical that such events happened on the required scale at that time, but it is worth considering how such sights would lodge in memory if they did. Even a smaller airburst limited to one region could become the seed of stories that echo for millennia. Whether or not a space rock was involved, the Younger Dryas left marks that we can still trace. In lake sediments, a sudden rise in pollen from cold-loving plants records the return of tundra conditions. In loess and dune fields, increased dust accumulation shows stronger winds and drier soils. In cave formations such as stalagmites, changes in oxygen isotopes track shifts in rainfall patterns. Every archive we open from this period seems to agree on one point. The climate did not glide smoothly into the present, it lurched. For people, that lurch meant yet another round of adaptation in a world already transformed by floods and rising seas. Some groups may have moved back toward refuges that had served them well during the full glacial period, such as sheltered valleys and low-elevation belts near persistent water. Others may have pushed into new territories as previous residents moved on or died out. Contact between groups could have intensified. Conflict and exchange both likely increased. This period also overlaps with important transitions in how humans made a living. In some regions, communities that had begun to rely more heavily on wild cereals and early cultivation strategies may have been forced to reconsider. In the Near East, for instance, the cold and dry Younger Dryas seems to have put pressure on wild plant resources that people had become accustomed to harvesting. One idea is that this pressure helped push experimentation with more deliberate planting and more permanent settlement once the climate improved at the end of the cold phase. Seen that way, the Younger Dryas becomes not just a weird blip in a temperature graph, but a meaningful stress test that shaped the path toward agriculture and settled societies. It was part of the background that set the stage for later cities and written histories. Without that final climatic jolt, the timing and geography of the first farming cultures might have been very different. The Great Flood and the Great Cold may have acted together to funnel human choices into narrow channels. From our modern perspective, there is another reason to pay attention to this episode. It shows how sensitive the climate system can be to pulses of fresh water and changes in circulation. We are used to thinking of climate change as something slow and predictable, unfolding over centuries at a steady pace. The Younger Dryas reminds us that thresholds exist. Push a system far enough, and it can respond with abrupt, non-linear jumps. What looks like a gentle slope can hide sharp steps. We are also drawn to this story because of the way it blurs the line between myth-worthy catastrophe and sober science. When you hear about sudden cold returning, strange materials in a thin, dark layer, and possible fire from the sky, it is easy to slip into the language of legend. The challenge is to hold on to the wonder and fear that such events deserve, without letting them pull us away from what the evidence truly supports. We have to be comfortable sitting with uncertainty. In the end, whether the Younger Dryas was triggered by a rerouted flood from a glacial lake, by an impact in the wrong place at the wrong time, or by some mix of both, the effect on lived experience would have been similar. A planet in transition from Ice Age to Warm Age paused, shivered, and then resumed its long climb. During that pause, people and animals had to improvise in landscapes already reshaped by megafloods and rising seas. If we want to understand how the end of the Ice Age carved scars we can still walk through today, and how it etched itself into the deepest stories humans tell about floods and endings, we now have another piece of the puzzle. The climate did not simply warm, it convulsed. In the next stage of our journey, we will step away from ice cores and pollen diagrams and return to the ground, into the paths of the megafloods themselves, to see how they ripped open valleys and rewrote the maps that people once trusted. If you want to understand what a megaflood can do, you have to walk the ground it scarred. Imagine standing in a dry canyon that is far too wide for the small river that trickles at its base. The walls rise steep and bare, their faces scraped clean as if some vast hand raked them. On the floor of the valley, there are hills shaped like upside-down spoons, long and smooth, all pointing in the same direction. Nearby, perfectly rounded boulders the size of houses sit alone on flat fields, with no matching rock anywhere close. At first glance, this landscape feels wrong in a way that is hard to name. The modern river seems timid and out of place, like a child in an adult's clothing. The scale of the features does not match the scale of anything you can see moving today. Hills and channels look as if they were made for something much larger and fiercer than the streams that now occupy them. For a long time, people tried to force these clues into familiar stories of slow erosion. The key to unlocking this puzzle is to imagine the valley not as it is, but as it was for a few wild days. Replace the small river with a wall of water hundreds of meters high, thick with mud and shattered ice. Let that wall roar through at highway speeds, not once, but many times. Under that kind of assault, bedrock behaves almost like soft soil. It chips, it shatters, it polishes. Loose material is scooped up, rolled, and dumped in new shapes that match the flow. Those spoon-shaped hills are streamlined remnants of debris, moulded by water rushing past. The giant ripples on old lake beds record waves that were tall as buildings. The stranded boulders are fragments carried in the flood and dropped as the energy drained away. Once you accept that such flows are possible, the mismatched scale of the landscape suddenly makes sense. You are no longer looking at a quiet river valley. You are standing in the dry channel of a former cataclysm. The region that best showcases this kind of evidence lies in what is now eastern Washington and parts of neighbouring states. Before the end of the Ice Age, a tongue of glacial ice filled a mountain valley to the east and blocked the outlet of a mighty river. Behind it, meltwater gathered in a deep basin, forming a lake that stretched across much of western Montana. This was the lake we know as Missoula, a body of water so large it would drown entire modern regions. As snowmelt and glacial runoff fed the lake, its surface rose higher and higher. The ice dam that contained it looked immense, a cliff of blue-white frozen in place between the valley walls. Yet beneath the surface it was riddled with channels and weak points. Pressure from the rising lake forced water into every crack. Over time, hidden tunnels formed at its base. Warm water gnawed at cold ice, turning solid barriers into fragile arches. When the dam finally failed, it did not crumble politely. The breach widened in minutes to hours. Lake water that had been mostly still now had a path downhill. Gravity did the rest. Estimates suggest that at its peak, the outflow may have carried more water than all the rivers on Earth combined. The flood burst through the mountains, then spread out over the plateau, following every depression and weakness in the land. The torrent did not simply follow the old river channel, it tore new ones. It slammed into ridges and split around them, carving twin paths and leaving isolated mesas between. Where it slowed for a moment, behind a natural constriction, it dropped loads of gravel and boulders. When it surged again, it cut into those deposits and carried them away. In low areas, floodwater pooled into temporary lakes that later drained, leaving behind strand lines and silt. What makes this story even more striking is that it seems to have happened not once, but repeatedly. The ice tongue that served as a dam could advance and retreat with climate swings. After each failure, as long as the glacier still occupied that valley, the lake could refill. Each refill took centuries, each drain took days. The channeled scablands are the layered result of this cycle playing out again and again during the waning millennia of the Ice Age. If you lived downstream in those times, your whole world could be shaped by where you were when one of these pulses came. Groups camped high on plateaus might watch a familiar valley transform in a roar of dirty water, then stand in stunned silence when the water drained and a stripped, alien landscape emerged. Those caught on low ground might have no chance at all. Their traces would vanish in the grinding, tumbling chaos. Even people far from the main flood paths would feel some of the aftermath. Rivers would not return to their old courses. New lakes would appear where scoured basins intercepted groundwater. Routes that animals used for generations could become dead ends or dangerous traps. In the wake of a megaflood, the land would be full of both risk and opportunity. Freshly exposed soils and new wetlands might support rich growth, while unstable slopes and loose deposits could make travel hazardous. North America was not alone in this. On the other side of the Atlantic, the retreat of the great ice sheets left behind their own series of giant lakes and precarious dams. In northern Europe, an ice-filled basin once separated Britain from the continent. Meltwater collected south of the ice margin and sometimes escaped catastrophically. There is evidence that one such flood carved a deep channel through what is now the floor of the English Channel, helped turn a continuous land bridge into a set of islands. Further east, in what is now Siberia and Central Asia, high-altitude basins held lakes backed up behind glacial ridges. When those ridges failed, floods swept through the Altai and other mountain ranges, leaving giant ripples and terraces similar to those in the American Northwest. In each case, the pattern repeats. A large body of fresh water perched behind unstable ice or debris, a period of quiet filling, then a sudden release that cuts canyons in a geologic instant. Not all megafloods were tied directly to ice. In the interior of what is now the western United States, a great pluvial lake sat in a closed basin, fed by wetter glacial climate. When its level rose high enough, it spilled over a low pass and cut a new outlet. The resulting flood tore through what is now the Snake River corridor, enlarging waterfalls and gouging deep channels as it went. This event, the Bonneville Flood, shows that even without ice dams, large lakes can become agents of rapid change once they find a weakness. What links all these stories is the way they rewrite internal maps of drainage. Before a megaflood, water on a continent might trickle along certain main routes toward the sea. Afterward, some of those routes are gone, replaced by new channels, new falls, and new basins. The direction of flow can change. Watersheds that once were separate can connect. Old river valleys can be abandoned, their floors left hanging high and dry above newly incised gorges. We see the legacy of that rewriting in the number of rivers today that seem far too modest for the valleys they inhabit. These are often called misfit rivers. A narrow stream winds through a vast canyon. A gentle river meanders across a floor that was clearly carved by something much more fierce. When you walk along the banks of such a river now, it is hard to imagine the torrent that shaped the stone long before written history. All this fresh water from collapsing dams and overflowing lakes had to go somewhere. Eventually, every flood found its way to the ocean. For the ocean, each pulse was another step upward. Over the full span of the deglaciation, from the peak of the Ice Age to the present, sea level climbed by more than 100 metres. That rise was not smooth. It followed the same pattern as the floods that fed it. Long stretches of gradual climb, then shorter bursts when ice or lake systems failed in new ways. One of the most dramatic of these bursts, known to scientists as a major meltwater pulse, seems to have occurred around 14,000 years ago, with another sharp jump a bit later. During these windows, global sea level may have risen several metres within the span of a few human generations. That is still slower than the walls of water in a Missoula-type flood, but from the perspective of coastal communities, it is fast enough to matter deeply. If the shoreline near your home moves inland by a few tens of metres in your lifetime, you notice. If it moves by hundreds of metres over the course of your parents' and your children's lives, you are forced to adapt. Camps that once stood above the highest storms need to be rebuilt further inland. Paths to fishing spots lengthen. Low-lying forests salt up and die, replaced by marsh. What looks like a slow trend on a global graph feels like relentless encroachment when it eats your land, one season at a time. Every major pulse of meltwater from the interior acted like an extra shove on that advancing line. Local megafloods carved inland, then joined larger rivers, then delivered sudden slugs of fresh water to estuaries and shelves. Each surge could drown deltas, rearrange sandbars, and rework coastal ecosystems. For people living near river mouths, these events might show up as years when the tides seemed to reach a little higher, when fertile floodplains became more brackish, when familiar sandbanks vanished. From space, the end result was a slow but steady redraw of every continental outline. Broad plains that had been dry grassland and forest for tens of thousands of years disappeared beneath shallow seas. Fjords, carved by glaciers and later flooded by rising water, cut deeply into coasts that had once been continuous. Estuaries widened where rivers had more sea to meet. Shelf edges, once remote from human view, became the new true boundaries between land and deep ocean. From the ground, those changes meant that the most attractive, resource-rich zones on Earth were being squeezed. Remember that the exposed continental shelves were prime real estate. They offered rich fisheries offshore and fertile soils onshore. They supported diverse plant and animal communities. As water advanced, all that wealth had to compress into narrower bands against uplands. Human groups who had thrived along the old coasts faced a choice: follow the retreating shoreline and compete for space, or move into less familiar inland environments. It is easy to underestimate how disruptive that shift would be. For mobile hunter-gatherers, we tend to imagine that moving camp is just part of life. Yet there are profound differences between coastal and interior living. Coastal groups often depend on predictable tides, seasonal runs of fish and shellfish beds. Their tools, knowledge and social networks are tuned to that world. Moving inland might mean learning new food sources, new hazards and new patterns of movement. The megafloods that rewrote river valleys did not cover the entire planet, but their combined effect fed a global process that did. With every collapsed dam and drained lake, more of the stored water of the Ice Age moved into the ocean. With every metre of sea level rise, more of the shelves that once anchored early human life went under. The story of these floods is not just a story of strange landforms in a few regions. It is part of the reason why whole chapters of human prehistory lie on seafloors today. You can see hints of these lost chapters in places where the drowning was interrupted or incomplete. In some coastal caves, now partially flooded, divers find ancient stalactites that could only have formed in air, and hearths or artifacts on ledges that were once dry. In shallow offshore zones, sonar reveals old river channels and terraces that match the shapes of drowned valleys on land. In a few spots, tree stumps still stand rooted in place beneath clear water, their rings recording seasons that passed before the sea arrived. These glimpses suggest that the shelves were not empty, and that people did not always abandon them the moment waters began to rise. Many likely rode out the slow advances as long as possible, shifting camp upslope bit by bit, rather than retreating far inland at once. By the time the seas finally covered their last favoured spots, those communities might already have deep stories about land that used to be there, about forests that stood where waves now break, about paths that are now routes for fish. When we combine the physical evidence of megafloods with these hints of human presence, a more textured picture emerges. The end of the Ice Age was not a single great wave sweeping around the planet in a day, nor was it a gentle fade. It was a patchwork of explosive inland floods and creeping coastal advances, each with its own rhythm, all tied together by the global accounting of water. For people living then, the key experience was that maps could not be trusted for long. This unstable reality matters for more than just understanding the past. It influences how we interpret the oldest flood stories and myths left to us by later civilizations. When a culture preserves a tale about a world reshaped by water, it may be drawing on a memory that is not merely symbolic. It may echo a time when grandparents pointed at distant waves and told children that they once walked where the white line now lies. We are still in the early stages of exploring these drowned landscapes directly. Technology is finally catching up to curiosity. High-resolution sonar can map the seafloor in fine detail. Underwater vehicles can skim along ancient channels and terraces. As more of these surveys are done, we are likely to find more evidence of how megafloods and rising seas combined to reshape not just the land, but human possibilities. The next step in our journey is to leave the carved canyons and scarred plateaus and follow the water out onto those lost shelves. There, beneath shallow waves, lie the plains, rivers, and coasts that framed some of the most important migrations in our species' story. Understanding how they drowned is one thing. Understanding who lived there and how much of their world vanished without a trace is an even deeper challenge waiting just below the surface. When the ice withdrew and the Great Lakes drained, the first places to vanish under the rising sea were not the high cliffs we picture today. They were the wide, shallow shelves skirting every continent. Those shelves were not empty. They were plains and forests, river mouths and marshes, crisscrossed by animal trails and human paths. To see how much we lost when they drowned, we need to look not at what is left above water, but at the ghostly outlines just offshore. Start with a map of modern Southeast Asia. You see a cluster of peninsulas and islands that looks almost chaotic. Mainland Asia juts down toward the equator. Indonesia is a spray of fragments scattered into the sea. Australia and New Guinea lie further south and east, separated by patches of blue. It feels like a geography lesson built from broken pieces. Now imagine dropping sea level by more than 100 meters, back to its Ice Age position. The blue patches between many of those pieces vanish. Sumatra, Borneo, Java, and the Malay Peninsula fuse into a single vast subcontinent that stretches far out from the present coastline. This is the Sunda Shelf, a drowned landmass that once carried rivers, swamps, and tropical forests. Its low hills and broad valleys would have felt like an extension of mainland Asia, rather than a separate island world. What is now the South China Sea was, in large part, dry land. On that exposed shelf, rivers from what we now call Thailand, Vietnam, and southern China would have met in a tangled network, flowing across the plain toward a distant coast. Mangroves and estuaries lined that old shore. Inland, there were forests rich with fruit trees and wildlife. For human groups already skilled at living in tropical environments, this region would have been a paradise of resources, with short distances between inland hunting grounds and rich coastal waters. As the Ice Age ended and seas rose, the Sunda Shelf was not swallowed all at once. The shoreline stepped inland in stages. Low-lying basins filled first, turning into inland seas and gulfs. Rivers rerouted around new bays. Hills that had once been far from water became peninsulas and then islands. People living there would have seen familiar landmarks slowly cut off. A headland turned into a separate land across a widening channel, then finally fading behind the horizon. To the south and east lay another hidden continent, one that also only appears when you lower the sea. Drop the water and Australia, New Guinea, and the islands in between merge into a single landmass called Sahul. Instead of a narrow Torres Strait, there is a wide bridge of dry ground connecting what are now separate countries. The shallow seas of the Arafura and Carpentaria basins turn into plains and lakes. The coastline pushes far beyond its modern position. When the first humans reached this region, they did not have to risk open ocean crossings as wide as we imagine today. They could move across exposed shelves, hopping between short stretches of water and long stretches of land. Once there, they spread across Sahul, hunting marsupial megafauna and exploiting the unique ecosystems of this southern world. Their oldest rock art and tools now sit on the pieces that stayed above water, but their earliest coastal camps may lie on seabeds we rarely visit. As the warming continued, waters crept in from the edges. The low bridge between Australia and New Guinea shrank, then broke. What had been a continuous coastal zone became two separate arcs facing each other across a growing strait. Shallow inland basins filled, turning plains into internal seas. For people whose lives revolved around the old coastal routes, this would have felt like their world was literally cracking apart beneath them. On the other side of the planet, a very different drowned land tells a similar story. Between Siberia and Alaska, there is a wide, shallow platform beneath the Bering and Chukchi seas. During the Ice Age, that platform was dry, a windy steppe stretching hundreds of kilometers from Asia to North America. This was Beringia, a bridge that was not just a narrow strip of land, but a whole region with its own climate, rivers, and ecosystems. Beringia was cold, but it was not a solid sheet of ice. Grasses and low shrubs grew on its soils. Mammoths, bison, and other large grazers moved across it in great herds, followed by predators and people. For humans, this land was both a corridor and a home. They could live there for generations, hunting and gathering on the open steppe, while slowly exploring routes into the deeper interior of the Americas. When sea level was low, the coastlines of Beringia sat far out from the modern shores. Rivers that now enter the Arctic Ocean flowed across a much wider plain before reaching the sea. As the ice sheets to the south and east melted, water gradually invaded this world. First it flooded low-lying valleys, turning them into long bays. Then it linked those bays, cutting through saddles and low passes. Finally, it drowned the entire plain, leaving only the high ground of the modern Aleutian and Diomede Islands as hints of the old landscape. Today, when we look for traces of the first people to cross into the Americas, we often search on the modern coasts and near inland valleys. Yet many of the most important camps, kill sites and meeting places from that journey may lie under cold, shallow seas where few archaeological expeditions can reach. The bridge that carried our species into a new hemisphere has been erased from the map that we can easily walk. Closer to later centres of civilization, another vanished land plays a quieter but still powerful role in our understanding of drowned coasts. Between Britain and continental Europe, the modern North Sea is shallow compared to the open ocean. Beneath its waves lies a patchwork of channels, banks, and plains that once formed a continuous landscape known as Doggerland. When sea level was lower, this region was a broad, low country of rivers, wetlands, and gentle hills. Imagine standing where the Dogger Bank now sits, not as a fisherman on a boat, but as a hunter on dry ground. To the west and east, you could walk to the higher land that would one day become Britain and Europe. Rivers wound through marshes rich in fish and birds. Herds of deer and other game moved along their edges. People built seasonal camps near reliable water and good vantage points, returning year after year. As the seas rose after the Ice Age, Doggerland slowly shrank. Low areas became lagoons. Rivers found shorter routes to the widening North Sea. Salt water intruded along estuaries. In the later stages, what has been a continuous plain fragmented into a network of islands and peninsulas. Storm surges from the Atlantic, riding on a higher baseline sea level, could sweep far inland, destroying camps and reshaping sandbars. Eventually, waves closed over the last dry ridges. The land bridge vanished, and Britain became an island. We know Doggerland existed not only from seafloor maps, but from what fishing and survey vessels pull up from the depths. Peat chunks from ancient wetlands, bones of mammoth and deer, flaked stone tools that once lay on the surface. These finds are scattered and hard to interpret, like pieces of a jigsaw puzzle recovered from a muddy floor. Still, they tell us that humans shared this drowned landscape with Ice Age animals, and that it mattered to them enough to leave traces. Drowned coasts are not limited to the high latitudes. Around the Indian Ocean and the Arabian Sea, broad shelves lie just offshore from major river mouths. When sea level was lower, the Indus, Ganges and other great rivers would have flowed across much larger deltas, with networks of channels and islands now submerged. The modern coast of Western India and Pakistan gives way underwater to terraces and paleo-valleys that suggest ancient shorelines and river courses. There have been claims of complex submerged structures in some of these regions, stories of lost cities lying on the seafloor. Many of those claims are controversial or unproven, tangled with wishful thinking and misinterpreted natural formations. What is solid is simpler and still profound. The shape of the shelf shows that the coastline has migrated tens of kilometres since the last glacial maximum. Any small ports, camps or ritual sites built along those old shores would now be in water too deep for casual exploration. Off the eastern coasts of the Americas, similar stories play out. The continental shelf off the southeastern United States is broad and shallow, extending outward before dropping sharply into the deep ocean. During the Ice Age, that shelf was an extension of the coastal plain. Rivers like the ancient version of the Mississippi or smaller streams along the Atlantic seaboard carved far across this surface. Florida was wider, its peninsula stretching further into what is now the Gulf and Atlantic. In the Caribbean and along Central America, lower seas turned scattered islands and cays into higher hills on continuous land, altered the shapes of bays, and shifted the paths of currents. People moving along these coasts at the end of the Ice Age would have hugged shorelines that simply do not exist today. The sheltered coves they used for landing boats, the headlands they used as navigation markers, the sacred promontories they climbed to watch the sea, may now all be underwater. If you zoom out from any one region and look at a global map with the sea drawn 100 meters lower, one theme stands out. The amount of habitable land lost at the end of the Ice Age was enormous. Some estimates suggest that an area larger than modern South America lies on the drowned continental shelves. Not all of that was equally suitable for human life, but a significant fraction would have been prime coastal habitat, exactly where we know people like to live. That raises a simple, uncomfortable question. If humans were present on Earth for tens of thousands of years before the final rise of the seas, and if so much of the best land for settlements now lies underwater, how many of our early experiments with complex coastal living have we simply lost? We are not talking about forgotten empires with skyscrapers and satellites. We are talking about dense networks of villages, seasonal fishing grounds, trading hubs, and ritual sites that could anchor oral traditions and social memory. We can get a hint of what might be missing by looking at what survived on land just inland from the old coasts. In many regions, we find early shell middens, piles of discarded shells and bones that mark long-term use of particular spots. We find campsites repeatedly occupied over generations near stable freshwater sources. We find early evidence of deliberate landscape modification in the form of controlled burns, small earthworks, or planted groves. These are the traces of people who already knew how to settle and intensively use a landscape, even before formal agriculture. If that level of sophistication is visible at the ragged inner edge of the drowned shelves, it is reasonable to suspect that the more favourable core zones, closer to the old shore, might have hosted even richer activity. Those hotspots would have been first in line to drown as the sea rose. They would also be among the hardest places for us to investigate now, buried under layers of mud and sand on seafloors that are dangerous or expensive to reach. Underwater archaeology is slowly pushing against those limits. Researchers use multi-beam sonar to scan the seafloor, creating detailed maps of old channels and terraces. They deploy autonomous vehicles and remotely operated tools to take cores and photographs. Divers explore flooded caves and submerged karst systems where ancient shorelines intersected limestone, finding human and animal remains preserved in dark water. Each new find proves the basic point again. People were there. They used these places. They left traces when the sea was lower. The challenge is scale. The world has hundreds of thousands of square kilometres of continental shelf. Only a tiny fraction has been examined at the resolution needed to spot archaeological sites. Even when we know where to look in a broad sense, such as near old river mouths or on former lake margins, silt and sediment can hide smaller features. Storms can disturb older layers. Industrial activity can destroy or scatter artifacts before scientists even know they exist. So we are left with a strange imbalance. The parts of the ancient world that survived above water are the most accessible and heavily studied. The drowned coasts, which may have been just as important or more so for early humans, are the least explored. Our picture of prehistory is biased toward uplands and inland valleys that escaped drowning. It is as if we were trying to reconstruct the history of a modern coastal society while ignoring everything that happened in its ports and seaside towns. Despite these gaps, the broad outline is clear enough to shape our imagination. During the final millennia of the Ice Age, human groups spread across continents using corridors and coasts that no longer exist. They built lives on shelves that now lie under shallow seas. As the ice melted and megafloods fed the ocean, those shelves shrank. Plains became islands, islands sank, bridges vanished. People were forced to move again and again, retreating upslope from a sea that never stopped climbing. When you remember this and then listen to the oldest flood tales preserved by later cultures, they sound different. Stories about lands swallowed by the sea, about islands that disappeared, about ancestors who walked where waves now roll, take on a new weight. They are no longer just metaphors for personal rebirth or moral judgment. They may also be dim echoes of real landscapes that are physically gone. We cannot interview the people who watched their hunting grounds drown or their coastal camps fall into the surf. We can only read the stone and mud and listen to the stories their descendants told thousands of years later. In those stories, water often plays a double role as both destroyer and creator. It washes away old worlds, but it also clears ground for new beginnings. That dual image fits the physical reality of the end of the Ice Age uncomfortably well. To test this connection, we have to leave maps and sonar behind for a moment and step into mythology and oral tradition. We have to ask how long a story can survive in spoken form, what details it can preserve, and how those details might line up with real floods and drowned coasts. The shelves may be silent now, but the people who lost them were not. The next voices in this investigation come not from ice cores or seafloor scans, but from epics, legends and warnings passed down in human words. For most of human history, the future was invisible and the past was carried in memory. People did not have maps of ancient coastlines or graphs of sea level. They had stories, told around fires, repeated during rituals, and carved into poems and songs. Among those stories, one theme appears again and again in cultures that never knew one another. Water rising where it should not, worlds drowned, survivors clinging to high ground or a vessel, while everything familiar disappears under waves. In the river valleys of Mesopotamia, long before later scriptures were written, storytellers spoke of a righteous man warned of a coming flood. They described towns swallowed, fields erased, and a boat or barge carrying seeds of life through chaos. In the highlands of Greece, another tradition told of a couple who survived a world flood in a chest and watched the waters recede, leaving them on a mountain slope surrounded by silence. In the vast mythic cycles of India, there is the image of a figure guided to safety by a great fish as waters rise to cover the land. Across the world in Australia, some Aboriginal stories describe coasts that extend far beyond the present shoreline and ancestors who walked to islands that are now submerged. The sea in these accounts is not static. It moves inland, swallowing campsites and sacred places, forcing people to retreat. In parts of the Pacific, there are tales of great waves that overrun islands, followed by new arrangements of land and sea. Among indigenous groups along the Pacific Northwest of North America, some stories speak of waters that suddenly surged far up valleys, carrying logs and animals in frantic flight. On their own, any one of these stories could be dismissed as a moral teaching wrapped in dramatic clothing. Floods are powerful symbols. They wash away corruption, reset the world, and offer a clean slate. It is tempting to see them purely as metaphors for ethical renewal or spiritual transformation, yet the global pattern is hard to ignore. Many cultures, separated by oceans and time, chose the same element to represent their most serious endings and beginnings. The question is whether those endings and beginnings were purely symbolic, or whether they also carried echoes of real events. Here is where the study of oral tradition becomes surprisingly important. For much of the 20th century, scholars tended to assume that spoken stories decay quickly. Details shift, timelines blur, and after a few centuries, they believed, any clear link to real phenomena would be gone. Recent work suggests a more complicated picture. In some indigenous societies, oral histories are not casual folk tales. They are carefully maintained records, recited with fixed structures and checked by elders. They may encode details of landscape, animal behaviour, and past events in forms that allow them to survive for very long periods. Studies of stories describing volcanic eruptions, for instance, have found striking matches between oral accounts and geological evidence for specific eruptions that occurred thousands of years ago. Consider a coastal group that has lived near a distinctive mountain for countless generations. At some point in the deep past, that mountain erupts catastrophically, raining ash, causing darkness, and reshaping rivers. The people who witness it create stories that explain what happened, often in terms of spirit beings or ancestral conflicts. They teach that story to their children as part of rituals. The core events are wrapped in symbolic clothing, but certain details remain surprisingly stable. The mountain once quiet, the sudden fire, the darkness at noon, the new shape of the land. Centuries later, when geologists study the volcanic deposits in that region, they can date the eruption and reconstruct some of its effects. When they then listen to the local stories, they find that key elements align with the known history. The story is not a journal entry, but it is not pure fiction either. It is a memory stretched across hundreds of generations, anchored by landscape features that still exist. If that can happen with fire and ash, it can happen with water and coastlines. In the case of floods and rising seas, the anchor is often a specific place. A rock outcrop that used to stand on dry land beside a village and now lies offshore. A channel that was once a river and is now a tidal inlet. A hill that has always been the refuge in big storms where people climb when the water comes. These anchors give storytellers concrete reference points. When they say that their ancestors walked across a space that now holds water, they are comparing something remembered with something visible. One example often discussed involves Aboriginal groups along parts of the Australian coast. Some of their stories describe particular stretches of shoreline, including offshore features, in ways that match what we know of those coasts when sea level was lower. The implication is that the stories preserve a memory of rising seas that took place 7,000 to 10,000 years ago. That would mean spoken narratives carrying geographic information across hundreds of generations without losing the core pattern. There are similar hints in stories from the Pacific Northwest, where traditions describe major coastal changes, sudden floods, or the sinking of land, and from Pacific Islands, where tales of great waves coincide with evidence for past tsunamis. In some cases, the match between story and geology is still debated. In others, it is hard to dismiss. The important point is that oral tradition can preserve recognizable traces of real environmental events far longer than many people once thought. How does this connect to the drowned shelves and megafloods of the Ice Age? The timelines are not identical. The main pulse of sea level rise that swallowed the continental shelves ended roughly 6,000 to 8,000 years ago, depending on location. That is within the outer range of what seems possible for oral traditions, but near the edge. The catastrophic inland floods from ice dam failures happened earlier still. The people who directly watched a wall of glacial water roar past are long beyond the reach of even the best preserved stories. Yet their descendants did not live in a vacuum. The environmental consequences of those floods, the rearranged rivers, the drowned valleys and the rising seas, persisted and even intensified in the millennia that followed. Communities living after the most violent pulses would still experience the legacy. They would watch coasts advance. They would inherit landscapes already scarred, carved canyons, and mysterious large channels that local rivers barely filled. They would have to explain why the world looked the way it did. This is where myth does its most important work. It binds people to land by giving every odd feature a story. A stranded boulder on a hill becomes the stone dropped by a giant. A canyon too large for the current stream becomes the path gouged by a sky serpent or a wrathful spirit. A line on a cliff far above the water becomes the mark of the highest wave in the time of their ancestors. These stories create emotional maps that sit on top of physical maps. Over time, the original cause of the feature is less important than the shared meaning. Still, some of the original observation can survive. When a community tells its children that the sea once stood far lower or far higher, and points to a visible mark, they are passing on a piece of environmental history encoded in narrative form. When they describe ancestors fleeing a rising tide that did not recede, they may be echoing real episodes of rapid sea level rise or local land subsidence magnified by global change. Of course, not every flood story matches a specific event. Some are more like pressure valves for universal fears. Water is unpredictable. Rivers can swell with rain. Storm surges can leap over familiar barriers. Even in a world without Ice Age scale change, Any culture living near coasts or rivers will experience destructive flooding eventually. It makes sense that they would build those experiences into their spiritual and moral systems, using water as the ultimate image of cleansing and judgment. The challenge is to separate the universal symbolism from the potential historical core. Scientists and scholars who attempt this have to walk a fine line. On one side lies the risk of dismissing all myths as fantasy and missing genuine insights into past events. On the other lies the temptation to seize on every similarity as proof of ancient global disasters, stretching stories far beyond what evidence supports. The goal is a careful, humble reading, where geology and narrative are allowed to inform each other without being forced into perfect agreement. When we look at flood myths in this cautious way, a pattern emerges. Many combine a local disaster with a larger frame. A great city in a low valley is drowned, but the story is told as the end of the entire world known to its people. A river bursts its banks and carves a new channel, but the story describes the gods reshaping the earth. This makes sense. For the people who lived there, losing their primary centre could feel like the end of everything that mattered. Now imagine generations of such stories layered on top of each other in regions where the background sea level is also rising. A community loses land to a storm surge and tells a story about divine anger. A century later, they lose land again, but now the baseline sea is higher, so the damage is greater. Their story might link the two events and stretch the timeline, creating a sense of one long era of rising waters. Over many centuries, the myth may distill various episodes into a single great flood that stands for an entire age of change. By the time writing appears and later scribes record these stories, they have already been shaped by countless retellings. They are polished into narratives with clear beginnings and endings, heroes and villains, moral lessons and divine interventions. The messy reality of staggered sea level pulses and scattered local floods disappears into a more coherent structure. Yet sometimes the text still preserves odd technical hints that feel geological. Specific mountain names, references to multiple weeks of rain followed by water retreating and leaving new ground. It is important not to overread those hints. The fact that a story mentions a mountain does not mean we can draw a line from its peak to a specific flood event, but it does suggest that the storytellers cared about certain locations enough to anchor their myths there. Those places might have been prominent refuges in times of real high water. They might have been the spots where people gathered to re-establish order after losing their homes. The mountain in the story becomes the symbol of survival, because a mountain in the landscape was actually where people survived. All of this becomes more poignant when we remember how much of the old coastal world is now gone beyond easy reach. The people who later settled inland valleys and founded early agricultural communities carried their myths with them, but not the lost land itself. To them, the old coasts lay in the realm of memory and sacred geography. You could not visit them, you could only talk about them. That distance makes it easier for myth to gradually slide from history toward cosmology. The most intriguing cases are those where multiple independent traditions in a region seem to point toward the same kind of change. Some Pacific Island cultures, for example, share tales of a time when certain reefs or sandbars were dry enough to walk across, and when later generations had to use boats instead. In parts of northern Europe, scattered references to lands drowned beneath the sea and bells still ringing beneath the waves may echo the loss of low countries like Doggerland, even if filtered through later storm surges and medieval floods. There is also a psychological layer that cuts across all these traditions. Floods are one of the few natural disasters that can transform a world overnight on a human scale. Earthquakes can topple buildings and reshape hills, but they usually do not redraw coastlines. Fire can sweep through forests or cities, yet land remains mapped in the same way. When water comes in fast and deep, it erases boundaries that felt absolute. The field line, the road, the edge of the village, all vanish in a continuous surface that reflects only the sky. For people whose identity is tied to particular places, that erasure is traumatic. It may not be enough just to say that a bad storm came. The story needs to be big enough to match the wound. That is where world-ending flood myths come from, at least in part. They give scale to the feeling that the entire structure of life has been washed away. The survivors in such stories are not just individuals who got lucky. They stand in for everyone who must now rebuild in an altered world. Now bring this back to the end of the Ice Age. Imagine a community that has already lived through centuries of rising water, watched fields and forests shrink, and moved camps multiple times. They have stories explaining these losses. They also know that their grandparents warned them that the sea was not to be trusted. Then a particularly extreme year arrives, perhaps driven by a storm tide riding on a higher base level, or by a local collapse of land. Waves go further inland than anyone has ever seen. Villages that thought themselves safe are destroyed. For the survivors, this event becomes the Great Flood in their narrative, even though it sits at the tail end of a much longer process. When they say that the entire world was covered, they mean the world they knew and cared about, the low country and coast that defined their lives. They inherit a physical environment already shaped by megafloods and drowned shelves, and they interpret their own disaster in that longer, largely invisible shadow. What is haunting about this is that we are in a similar position now, but with more tools. We can watch ice sheets melt from space. We can measure sea level change with satellites and tide gauges. We can map drowned valleys in stunning detail. Yet when storms combine with high tides and flood modern coastal cities, our stories and headlines still often frame them as sudden, shocking intrusions into a stable world. The difference is that we know, at least in principle, how sensitive our coasts are to small shifts in sea level and circulation. We understand that a slow background rise can turn a regular storm into a disaster. The people at the end of the Ice Age did not have that framework. They had mythology instead. Their flood stories are artifacts of that gap. They are attempts to make sense of living on moving borders without ever seeing the full chart. Listening to those stories with fresh ears does not mean abandoning science. It means adding another layer to the picture. Geological evidence tells us what happened and when. Oral tradition and myth hint at how those events felt and how they were woven into cultural memory. Together, they suggest that the end of the Ice Age was experienced not as a mild springtime, but as a series of endings and forced restarts along the coasts. The question that remains is how those repeated shocks shaped the next big turn in human history. As seas rose and shelves drowned, as flood memories hardened into myth, people in some regions began to stay put more often, to plant seeds, to build villages that would become towns. Whether by necessity or opportunity, they traded the mobility that had helped their ancestors survive the great floods for a new kind of rooted life. Understanding that choice is essential if we want to see how a drowned world helped forge the first civilizations that left their own written records of creation and loss. When land keeps disappearing, staying on the move feels like the only safe answer. For a long time, that was our strategy. People followed herds, shifted camps with seasons, and walked away from failing landscapes. Mobility was a shield against bad years and bad luck. But there comes a point where there is nowhere easy left to run. By the end of the Ice Age, in some regions, that point had arrived. Along shrinking coasts and crowded river valleys, groups who had retreated upslope several times already found themselves pressed against other communities doing the same. The best hunting grounds were contested. The richest wild plant patches were harvested hard. Old escape routes across shelves and land bridges were gone, replaced by water. In this tightening net, the old way of life did not stop working all at once, but it became more fragile. Imagine a community in a hilly region near a river that has become unpredictable. They used to hunt on a broad floodplain that stretched far outward, now drowned. They used to fish in easy backwaters, now turned into deep estuaries where tides rule. They can still survive by moving, but every move brings them into contact with neighbours doing exactly the same thing. Negotiations, alliances, and conflicts take more energy. Food, in bad years, comes a sharper question. In that context, the idea of tending particular patches of land, of encouraging useful plants to grow where you will be later, stops being a luxury. It becomes a hedge against chaos. People who had long understood plants as wild resources begin to see them as partners and projects. They scatter seeds near camp, prune trees, and clear competing shrubs. At first, these actions blend into foraging. Over time, they push toward cultivation. The regions where this shift shows up earliest in the archaeological record share a simple trait. They are places where climate and geography squeezed people between rising seas, drying or shifting rainfall, and crowded corridors. The broad arc from the eastern Mediterranean through the highlands and plains of what we now call the Fertile Crescent is one example. Here, the end of the Ice Age brought warmer, wetter conditions at first, then the Younger Dryas chill, then renewed warmth. Wild cereals grew thick in some valleys and foothills. People who had once passed through these areas seasonally began to linger. They built more permanent shelters. They ground grain with stones. When the Younger Dryas made the climate harsher and wild grain yields less reliable, the value of deliberately planting and tending fields rose. By the time warmth returned for good, some communities were committed to cultivated crops in a way their ancestors had never been. Another example lies along the Nile. The Nile Valley and its delta form a narrow ribbon of fertility in a broader desert. When sea level was lower, the river met the sea further out on the shelf. As water rose, the delta complex shifted inland, compressing wetlands and fertile lowlands into a smaller area. People who depended on the Nile's annual floods could no longer rely on a wide, shifting mosaic of channels and marshes far out on the plain. The river's gift was still there, but concentrated. In such a setting, it made sense to learn the rhythm of the flood very closely, when it rose high, when it dropped, and where it left silt. Over generations, communities figured out that planting seeds on freshly deposited mud could yield dependable harvests. They began to clear and shape small plots, to watch the river with a planner's eye rather than only a hunter's. The river, which had once spread across a broader plain closer to the sea, now became a tighter spine around which new, more settled lives could grow. To the east, in the valleys that would later host the great cities of the Indus region, a similar story unfolded. Mountains fed rivers that rolled across an alluvial plain. When sea level was lower, the coast and delta of these rivers lay farther out, and the plain stretched into the shelf. As water rose, the zone where river and sea met slid inland. Flood patterns changed. People living there adapted, as they had always done, but some adaptations involved building more fixed fields and small structures rather than only moving. In East Asia, along the Yellow River and the Yangtze, shifting monsoon patterns, changing rivers, and rising coastal waters created their own pressures and opportunities. Lush soils in the north held water and nutrients in ways that rewarded digging and planting. Wetlands in the south were perfect for early management of plants in damp fields. In each of these distant regions, different plants and different techniques anchored the change, but the underlying pattern was similar. A world of moving coasts nudged people toward making islands of stability on land. You can think of this shift not as a sudden invention, but as a series of experiments stretched over many generations. A group might discover that leaving some plants standing and not harvesting all their seeds makes next year's patch fuller. Another might notice that sowing seeds in disturbed soil near camp gives a better yield. A third might find that building a small levee around a patch keeps floodwater at just the right depth. Most experiments fail or only partly succeed. A few work so well that they become tradition. As these traditions accumulate, mobility patterns change. People still move, but within a smaller radius. They rotate between a set of villages rather than across a continent. Their wealth becomes tied up in fields, orchards, and stored grain, not only in knowledge of moving herds and seasonal wild patches. That stored grain allows them to survive bad years more often, but it also roots them. Leaving is now harder, because leaving means abandoning heavy investments in place. This new relationship with land would have felt risky and promising at the same time. On one hand, it offered a way to tame the unpredictability of a shifting climate and rising seas. On the other, it made communities more vulnerable to local disasters. A bad flood, a new channel cutting through fields, or a saltwater intrusion into irrigated land could wipe out your entire safety net. The same water that once chased your ancestors inland now threatened your fixed villages. In many floodplain cultures, you can still see this tension in their oldest stories. Rivers are worshipped as life-givers and feared as destroyers. Floods are both blessings that renew soil and curses that drown crops. Gods of water are often double-faced. They bring fertility and catastrophe. When scribes later wrote down these stories, they wrapped them in the language of kings and courts, but the underlying emotion comes from parents watching fields disappear underwater that is both familiar and treacherous. At the same time, the move towards settled life changed how people thought about time. Hunter-gatherers live on scales of days, seasons, and migrations. Farmers live on cycles of planting and harvest, on years and multi-year planning. When you build terraces or canals, you are making a bet that you and your children will still be there to use them. That bet makes the idea of a stable world more attractive. It also makes the prospect of another great flood more frightening. The earliest monumental structures we know of in some regions seem to appear right around these transitions. Stone circles, mounds, and gathering places built by communities that are not yet full farmers, but already more settled than their ancestors. These sites often sit on high ground, above floodplains. From them, people could look out over the surrounding land and the rivers that fed it. They were places to meet, trade, and perform rituals that bound scattered groups into a shared identity. It is tempting to see these early monuments as part of a collective response to a world that had recently proven it could erase whole coastlines. Building in stone on hills is a way of saying that something of us will remain, whatever the water does. At the same time, the gatherings at such sites would have been perfect moments to retell the old flood stories and to fold new experiences into them. The memory of drowned shelves and migrating shores did not vanish when agriculture began. It was carried into the new age as a warning. As villages grew into larger settlements, and those settlements into the first cities, the relationship with water only deepened. Early urban centres often formed along rivers that could be managed with irrigation. Canals, levees, and reservoirs turned seasonal floods into more controlled cycles of watering fields. But every wall and channel added another layer of dependence. A failure of water management was no longer just a bad year. It was a crisis that could topple rulers and wipe out thousands. Ancient texts from later periods, long after the Ice Age, still carry echoes of dread about water rising beyond control. They speak of gods using floods to punish arrogance, of rulers tasked with keeping rivers in their banks, of heroes credited with taming waters. In some traditions, the same figure who survives or manages a great flood also brings knowledge of farming or law. The link between order after chaos and the birth of structured society is not accidental. Think about what a flood does to social ties. In a mobile world, a local disaster might scatter a band, but they could regroup elsewhere. In a settled world, a severe flood can wipe out records, buildings, and fields in one sweep. Survivors must decide whether to rebuild in the same place, move collectively, or fracture into smaller groups. How leaders handle these moments shapes trust for generations. The story of who saved whom in a flood becomes part of political legitimacy. In this way, the legacy of the great floods at the end of the Ice Age lingers long after the last great ice sheets are gone. They set the stage for a new kind of vulnerability. Our ancestors traded the flexible resilience of movement for the productivity and density of settled life. That trade allowed cities, writing, and complex cultures to emerge. It also created societies that could be shattered more completely by water than any small band on a coastal shelf. You can see that fragility in the places where early civilizations took root. The fertile arc between great rivers in the Near East, the narrow strip along the Nile, the floodplains of the Indus and its neighbours, the broad basins of northern China. In each case, human life clustered along water, in zones that had been reshaped again and again by past climate swings and sea level changes. The memory of lost land lay just offshore, invisible but not gone. As generations passed, the direct experience of drowning shelves and vanishing land bridges faded into the background. What remained were narratives of primeval chaos, of waters covering everything until divine or heroic action brought them under control. These narratives sat at the foundation of many cultures. They told people who they were, why their land existed, and what might happen if cosmic balance failed. The actual physics of ice and meltwater pulses had dropped out of awareness. The emotional truth of living in a world that can suddenly take land away had not. In a sense, early farmers and city dwellers built their entire way of life on a bet that the violent swings of the late glacial period were over. They assumed that rivers would keep following roughly the same paths, that seas would not climb another 100 meters within a few thousand years, that the climate would stay within certain bounds. For a long time, that bet paid off. There were local disasters, droughts and floods and tsunamis, but the underlying structure of coasts and climate brought no fresh surprises on the scale of drowned continents. This long stretch of relative stability is what we now call the Holocene. It is the warm, wet, but not too wild window that made agriculture and complex societies possible. It is easy to treat this window as normal. The deeper record shows that it is unusual. The ice age that came before it was full of large swings and rapid jumps. The greenhouse world we are driving toward now may be full of different extremes. For a brief moment in between, the planet calmed down enough for rice paddies, wheat fields, and cities of stone. The irony is that within this calm period, humans slowly became capable of recreating a kind of great flood on their own terms. By burning fossil fuels and clearing forests, we are now warming the atmosphere and oceans at a rate that rivals some of the most rapid past changes. Glaciers and ice sheets are retreating again. Sea level is rising, this time driven not by orbital cycles alone, but by our own actions. Seen against this backdrop, the ancient stories of rising waters and drowned worlds are no longer just curiosities from a distant age. They read like early case studies in what it means to live at the edge of a moving sea. Our ancestors watched their shelves drown and responded by tying themselves more tightly to land, building systems that assumed stability. We are now testing that assumption in ways they could never have imagined. If there is a lesson in the way a drowned world helped forge civilization, it is not only that catastrophe can lead to creativity, it is also that new forms of life come with new forms of risk. Agriculture and cities turned us into a species that depends on fixed coastlines and predictable rivers, even more than our foraging ancestors did. The floods that once scattered small bands now threaten millions in dense deltas and megacities. We are the heirs of people who made peace, for a time, with a once angry sea. We live in a world whose coasts were drawn in the final stages of a great natural flood that ended 12,000 years ago. As we stand on our own crowded shores, watching tide lines creep upward and storms grow stronger, we are not facing something entirely new. We are walking back into a story that began when the last ice age died. What remains is to ask how we will tell this chapter, and what kind of memory we will leave behind for whoever walks the high ground after us. Will our descendants speak of a time when we saw the waters rising and chose to adapt with foresight, or of a time when we ignored the warnings written in drowned valleys and old myths? The answer will shape not only our maps, but the stories that future people use to explain why their world looks the way it does. From far above, our world still looks calm. Continents sit in familiar shapes, wrapped in thin blue fringe where land meets sea. The bright lace of cities hugs that fringe, glowing along river mouths and coasts. It is easy from this distance to imagine that the outlines are fixed, that our maps show something permanent rather than a moment caught in motion. Drop closer and the illusion begins to fray. You see deltas carved into wedges that push into the ocean, their tips already fraying under waves. You see barrier islands marching slowly along coasts, eroded on one side and rebuilt on the other. You see dense neighbourhoods and skyscrapers crowded right up to the waterline, resting on land that only recently emerged from the long retreat of the ice. Our modern world has built itself on the youngest real estate on Earth. We did this because water makes things possible. Rivers carry trade, coasts connect continents, estuaries and shallow bays are rich in life. The same logic that drew Ice Age hunters to the shelves and drowned plains draws us to New York, Shanghai, Mumbai, Lagos, and countless other cities where land and ocean touch. It feels efficient, natural, almost inevitable. Only when the water starts to move do we remember the risk built into that choice. You and I have one advantage that no previous coastal culture enjoyed. We can see the sea level curve. We can look at instruments that record millimeters of change each year, and at satellite measurements that show ice sheets thinning. We can drill cores into mud on the ocean floor and reconstruct how fast the sea climbed in the past. We do not have to guess that the shoreline is mobile. We have proof. That proof comes with a shock. For most of the last several thousand years, sea level rose only very slowly. There were fluctuations, but on human timescales, coastlines were stable enough that villages became towns and towns became cities without being chased inland. Now the line has turned upward again. Glaciers are shrinking on mountain ranges. Greenland is shedding ice each summer that does not fully return in winter. The great ice sheets of Antarctica are losing mass at their edges, where warmer water gnaws at their base. Most of the water locked up in those ice sheets has not yet been released. If it were, sea level would rise by many tens of meters. That is not something that will happen in our lifetime. The point is not that we face an instant replay of the last deglaciation. It is that we have begun to push the system in the same direction that ended the Ice Age, but from a different starting point, with our own civilization perched precariously on the coasts. You can think of this as waking a giant that has been dozing. During the Holocene, the ice sheets were relatively stable. They advanced and retreated a little, but their contribution to sea level was small. Now we have added heat to the atmosphere and oceans. That heat is the soft but relentless tap on the giant's shoulder. The first signs of movement are subtle. A thinning here, a retreating glacier there, an accelerating stream on the ice surface that drops into a deep blue shaft. If you want to feel the weight of what this could mean, it helps to place our time on the same graph as those earlier meltwater pulses. When ice sheets crumble rapidly, sea level can jump by several meters in a few centuries. That is still slower than the Missoula-type floods that carved the Scablands, but for people living on coasts, a rise of a few meters in a handful of lifetimes is transformative. Many of our largest urban areas sit on ground that is only a few meters above the current high tide line. We do not need to imagine walls of water to see the danger. A simple shift in the baseline sea level turns once-in-a-century storms into once-in-a-decade events. A storm surge that would have barely overtopped a seawall 50 years ago now floods subway tunnels and power stations. Salt water creeps into groundwater, killing trees and crops from the roots. The floods become not singular legendary events, but a new background condition. Here is where the parallel with the end of the Ice Age becomes more than an academic curiosity. Back then, people lived on shelves they did not know were shelves. They adapted to a world that felt given, only to discover over generations that its edges were melting away. Today we live on coasts we do know are temporary. We understand, in principle, that the shore will not stay where it is if the planet keeps warming. The question is, what we do with that knowledge. At the same time, our ability to read the past has never been stronger. While satellites watch modern ice, ships and underwater robots map the drowned landscapes of the last deglaciation. Multi-beam sonar paints the contours of ancient river channels on continental shelves. These images show us valleys carved in air that now lie underwater, complete with terraces and side gullies. In some places, we can trace old shorelines as sharp breaks in slope, steps marking where the sea paused for a while before surging higher. Divers explore submerged caves that were once dry chambers above sea level. They find stalactites and stalagmites cut off mid-growth, their tips broken and smoothed by waves that flooded the caves when sea level rose. In a few, they find human bones and artifacts on ledges that served as shelters in a time before the ocean arrived. Submerged forests also tell their quiet stories. Tree stumps rooted in place on modern sea floors, their rings still readable, show where woodland once spread. Each of these discoveries helps us rebuild a mental image of the lost shelves. We can start to see where rivers braided across wide plains, where lakes collected, where gentle hills offered good vantage points above floodplains. Sometimes we even find clear signs of human presence, such as stone tools mixed with animal bones in sediments that date to times of lower sea level. Those finds are still few, but they are enough to prove that our ancestors used these landscapes heavily. You can think of underwater archaeology as a kind of delayed conversation between us and people who lived through the last great drowning. They left marks on the land. The sea covered those marks. Now, with machines and careful work, we are peeling back layers of water and mud to listen. What we hear so far is that they were creative and resilient, that they followed the moving coast for as long as they could, and that some of them began to root themselves inland as the water advanced. As we piece together their story, we are also mapping our own vulnerability. When we see that an area like the Sunda Shelf once supported rich ecosystems and probably dense human activity before it drowned, it becomes easier to imagine the Gulf Coast or the Ganges Delta as zones that could undergo similar long-term shifts. When we see how Doggerland went from continuous lowland to scattered islands to seafloor, we can better grasp the long arc of change awaiting some of our own low countries if ice melt accelerates. There is a sobering irony here. The same technologies that let us read the past and predict future sea level rise also allowed us to burn fossil fuels at a scale that drives the warming. We are both the historian and the agent of the next flood. Unlike Ice Age hunters watching the sea creep inland with no idea why, we know the rough cause of what is coming. We can calculate likely ranges of rise for different warming paths. We can model how ice streams might behave if buttressing shelves fail. That knowledge does not give us control. It does give us choices. We can slow the warming by cutting emissions, giving ice sheets more time to adjust and coasts more time to adapt. We can decide where to defend, where to accommodate, and where to retreat. None of these options is painless. All of them are better than pretending the shoreline is fixed. The more we treat our current coasts as eternal, the more likely we are to repeat the shock our ancestors felt when their shelves drowned. It is natural at this point to wonder how much of our world will survive in a form that is legible to distant descendants. Many of our grandest structures and densest cities sit on ground that may not be dry forever. If sea level rises by several meters over coming centuries, many iconic skylines will be lost or altered beyond recognition. Future underwater archaeologists, if there are any, will find steel and concrete instead of stone tools and buried forests on the continental shelves. Try to picture one of those future surveys. A small autonomous vehicle glides through greenish water above what used to be a major coastal city. Its sonar paints boxy shapes on the seafloor, the husks of towers and bridges buried in sediment. In some places, sediment has completely swallowed the remains, leaving only faint outlines. In others, parts of buildings poke from the mud, like the stumps of those ancient trees. Whoever studies that data will know, in an instant, that someone once built big here. What they will not know from rubble alone is why things changed. They will need stories, records, and memories to make sense of the physical evidence. If any of our archives survive on high ground or in durable forms, they may read about rising seas, melting ice, and debates over what to do. They may see that we had clear warnings and still hesitated. Or they may see that we managed to bend the curve, to slow the flood, and to move with it more gracefully than we feared. Either way, they will tell stories about us. They may turn graphs into legends, climate models into cautionary tales. Perhaps they will speak of an age when people believed the coasts were fixed, then knew they were not, yet found it painful to act. They will describe cities swallowed and new ones built further inland. They will talk about leaders who listened and those who did not. In their stories, the water will once again serve as both judge and setting. Our own myths about floods will not vanish in the meantime. If anything, they may become more resonant as storms and tides press harder against our defences. Stories of ancient deluges will feel less distant when we see modern neighbourhoods underwater in news images. You might already notice that language slipping in when people describe disasters today, speaking of roads turned into rivers and suburbs into lakes, of once-in-a-lifetime floods happening twice in a decade. There is a temptation to treat those parallels as pure coincidence, to say that it is just a human habit to dramatise bad weather. But if you have followed the path of this investigation, from drowned shelves and megafloods to myths and early agriculture, you know there is more beneath the surface. Our stories about water are shaped by events that really happened, by land that truly drowned. They are also tools that help us live with the knowledge that change on that scale is possible. Right now, we stand in a rare position. We can see backward into the last great flood through geology and archaeology. We can see forward, at least in outline, into the next centuries of rising seas through physics and observation. We sit at the hinge between those two views, with a chance to decide whether we will treat this knowledge as a warning or as a mere curiosity. You and I do not get to choose the planet's past. We do get to influence its future. Listening to the Ice Age, we hear that coastlines can move far and fast compared to human lifetimes, that floods on the scale of continents are not just fantasies, and that people can adapt, but at great cost. Reading modern data, we see that we are nudging the planet toward another era of shifting shores. Bridging these two sets of information is the work of imagination. We have to feel the weight of future drowned neighbourhoods as vividly as we feel the loss of Doggerland or Beringia. If that sounds heavy, it is. Yet there is a quieter, hopeful thread woven through this story. The people who survived the last great floods did more than endure. They learned, experimented, and built new ways of living in the wake of loss. They carried memories of drowned worlds into the age of fields and cities, and some of those memories reached us. We are the proof that survival after catastrophe can lead to richer, more complex cultures, not only to collapse. We cannot assume that our own outcome will be so generous. The scale and speed of what we are doing to the planet are different from anything that came before. Still, it is worth remembering that resilience is part of our inheritance. The same species that walked exposed shelves now designs satellites and sonar, writes climate models, and tells long stories about the deep past. The same curiosity that led us to map drowned rivers can guide us in reshaping our societies to live with rising seas. In the end, the Great Flood is not just an event at the end of the last ice age. It is a pattern of interaction between water, land, and human imagination that plays out whenever coasts move. 12,000 years ago, that pattern forced our ancestors to abandon the widest plains they had ever known and nudged them toward villages and fields. Today, it challenges us to rethink how we build, where we live, and what we consider non-negotiable. One day, far beyond our own lives, someone will stand on a new shore and look out at a different map of continents and oceans. They will know that the land under their feet was once seabed, and that lands now underwater once carried forests, roads, and cities. They will tell stories about how the world changed, and about the strange age when people first understood that change and had to decide what to do. We do not yet know which version of that story they will tell. We only know that we are writing its opening chapters now, on coasts drawn by the last great melting, under a sky warming with our own breath. If the drowned plains and ancient myths have anything to say to us, it is this: the sea is never truly still, and neither is history. What seems solid beneath your feet today can be gone within a handful of lifetimes. The real question is not whether the waters will rise, but how we choose to stand, move, and remember as they do.